Today we have Richard Medina, who is the co-founder and principal consultant with Labs. Going to dive right into the questions. You've been helping folks do capture since the 90s. Can you explain how artificial intelligence becoming more effective is changing IDP and making implementations more effective?
Let's start with just a little bit of history. So Dan Lucarini, a pundit in the space, breaks IDP into four phases. Basically, OCR in the 1960s, the era of forms and templates in the 80s and 90s, and then you get AI with machine learning, and now most recently, large language models or GPT. Now, I'm going to focus primarily, take a zoom in on the machine learning, AI, machine learning, large language models. So I'm going to zoom in on that. And I'll say in that piece, there are three phases. And the first is pretty much everything, well, phase zero, pretty much everything up to about 2016 was a linear increase in effectiveness, where accuracy was getting better and so on, but in a linear fashion. But about 2016 or so, we started seeing vendors who were able to use our AI and machine learning for classification, extraction, and validation, and with hyperscience and a number of others. So that let us do two things. First, where we got pretty good accuracy, we now with machine print on semi-structured documents or whatever. Now you could get really good accuracy. So you could move from 90 to 99 or 95 to 99.9. Secondly, with that in that era, 2016, 2017, 2018, and so on, you could do a better job at handwriting. Before it was completely, a lost cause. There was really no business case in doing it unless you had very constrained handprint. But typically, the QA process and error correction would be more timely and labor consuming than to make it worth it. So, but what you began to see is the ability to do the handprint. So now I'm answering your question, Bryant, in a sequence. So now we got really good accuracy on the stuff where we got pretty good accuracy, and we've got worthwhile accuracy on formerly intractable problems like handwriting. Then around 2000 or so, we began to get the unicorn, plus or minus. The unicorn was a term invented by, or whatever, just spewed out by a senior architect at one of our clients, a large insurance company. And he said, what we really need and what we're starting to do is you take this IDP and you put it as a front end onto RPAs, and you put all those IDP and RPA engines and so on a backbone, an orchestration backbone of an automation platform, and you use some other doodads and so on. And so that way you really get intelligent process automation worthy of the name. Before it was kind of stupid, now it's intelligent. Before it was just task automation, now it's process automation, and it really is automation. And so we began to see that that is the fundamental unit of usefulness for many applications, using IDP to front end RPA or whatever and orchestrate it and so on. So we thought that would be a linear progression, just executing on that blueprint. And that worked out pretty well. And that let you do a few other things. One, it really let you do straight through processing, because you could have with RPA, if it found a problem, it could shoot back to the beginning and correct it and so on. So you could have unattended processing for IDP. That was really good. The second thing we began to see is you could have, because this came at the same time as low code, no code, you could have, detached, you could have IDP as a service. And so a workflow way downstream in a line of business processing and claims or something like that, or marketing, if they needed something IDP'd, classified, extracted, validated, they could call a service, it would do it, and would hand over the result. And so that removed it from the capture center or for any scanning and so on. And that began to become really effective and really useful. And so we began to see the march again, as I said, of linear progression, and everything crashed down in 2023, where we really saw the advent of these large language models and so on. They had, their birth was really in 2017, but no one really saw them or took really good recognition of them until 2022, 2023. And so you began to do a number of things. So for example, the hyperscalers it was evident that they would become really important, Microsoft, AWS, and Google, And vendors like OpenAI and others who were really good at the large language models, you saw that they would become huge players. And you saw that this would, become a huge, apply great pressure on the vendors in the market that formerly had pretty good earlier generation AI, but had nothing, were not ready for this next generation. So what does this enable you to do? Well, it enables you to do almost everything. So it smooths out the difference between, it doesn't matter so much if the document is structured or semi-structured or unstructured. It can understand it. Um, it can do a much better job at the formally tractable, formally intractable, all the machine and handprint stuff. It does, but it can address other difficult problems like tables and checklists, which might have complex logic. It can do a good job on those if done properly. So that adds, again, some additional capabilities that I'm just mentioning, but there are some cautions. And so now we're going to look at the glass half empty. A good metaphor to use, I think, one that's been very useful in explaining the situation is that of, say, an electric car or cars in general, but let's focus on electric cars, where you have the core, the engine, and the engine can be old fashioned or it can be newfangled, like an electric engine. That's great. It can be 500 or 100 or 500 or 1,000 horsepower. That's great. But you need a car to wrap around it to make it work. So we'll call that the frame. So those are the components of the rest of the car, the chassis and body and wheels and so on. And then you need a supporting environment. So those external factors needed for overall success, like stable manufacturers and a supply chain and fueling stations and spare parts and mechanics and so on. So now we look over at IDP and you need the core, you need engines, and they can be, clunky ones from the from the aughts, so they can be more better ones, or they can be the new LLM models. But you also need a frame to make it work. It doesn't do any good if you just have this engine. And so for advanced AI-based IDP, you need capture, but you need human in the loop to be able to address the gaps in it. You need workflow and orchestration. You need administration and development and so on. And then you need the supporting environment for AI-based IDP. So you need the vendor stability. You need there has to be enough money and funding for research and development. There's got to be market share, and your company has to be able to consume the newfangled IDP approach. Now we get to the point. The point is no one does this. No one can put together the whole shooting match. So you go over to, newfangled LLM IDP, and there are the engine providers, and they're trying to get folks, either themselves, they provide somewhat of a car, somewhat of a frame, and they're trying to get partners who can do the rest of the frame. But a lot of these are one-offs or they can only do simple workflows. They haven't done a lot. There's a lot of stuff under the belt. Then you have the legacy IDP vendors, the usual name brands, and they're good at the frame, at the car, but they don't have the engines. And so they're trying to either develop the engines, which is probably going to be a loser, or they have to OEM partner and put in the high-end engines and so on. And then you've got to have the supporting environment. So that's the first issue. That's the first issue to think about with as you're embarking on this. I packed a lot of that into that piece with the car metaphor. So the first piece that you need, right, is that innovation. Second is the ability for the suppliers and yourself to productize it, to make it work and be sustainable. The third is for your organization to consume and put it into production. Make it work, where you're doing a lot of hand data entry. Now you've got to do a lot different things if it's completely automated, and save or make money out of it. And then finally, there's this primary challenge of the new LLM models, and that is the precision problem. And that is they hallucinate, they provide false positives. With great confidence, they BS you. And so the joke is, right, if you're asking for insurance company, member ID numbers, and you hand them a bunch of documents and they'll say 24, 25, 26, you hand them a menu, from a restaurant, and they say ham sandwich, and they just keep going with great confidence. The challenge with that is that if you are doing important stuff, like with numbers or with client information or regulated information and so on, you can't have those mistakes. And it's arduous today to do the QA on them and discover those false positives. So that's a problem that has to be addressed, which means that today they're really not up to snuff for doing a lot of the important numbers-based, high-value, high-risk work of your organizations. It's still time to do it, but they can be effective today if you had to do a POC or whatever. They can be effective where you don't need as much precision, and you can have mistakes and either have them go through or whatever.
So that was one question. So we got a second question coming up here. So we talked about a little bit of pros and cons and what this stuff is, and why it's hard. But what are two or three of the more interesting AI capture, AI/capture use cases that actually can be successfully implemented today?
To be successful, you should have, if you're looking for use cases, there should be enough innovation there. It doesn't have to be LLM. It could be an earlier generation of AI with CNN and RNN and so on. Very good stuff. But it should be innovative. So enough out of the box that you can do it, and you can use the result at your company, and you can have some kind of ROI out of it. It's not just a complete learning experience. As I said, where precision, you've got a precision addressed. Either if you have a very low tolerance for errors, you're doing enough QA to be able to make it work, or you can be a little bit sloppy. Okay, now with all that in mind, where are you going after? Well, any of the ones that I talked about, if you're using pre-LLM, so if you're using Unicorn, the 2017 or Unicorn assemblages of RPAs and so on, you can do the machine print stuff. You can do the difficult handprint stuff. You can do that. You can do the straight through processing. That is, and you can do the call IDP as a service. All of those are available to you. Typically, if you're new to this, right, you're looking at more simpler flows. Might be a difficult IDP problem, but not a difficult workflow problem. So a difficult engine problem, but not a difficult frame car rest of the problem, where you don't have a lot of human in the loop, you don't need a lot of orchestration and so on. So what does that mean? Well, my favorite are the call IDP as a service ones, where it's being called your workflow, whether it's Appian or Pega or File IBM or whatever, is calls IDP and then boom, gets a smart answer or some a generalization in that case. But what I mean by that is a fetch, understand, act sequence. One of the greatest uses of these of IDP, particularly the smarter versions, the newer versions, is to reduce the labor of having to fetch information that you need to make a decision. So for example, that's the RPA situation. The RPA needs to get information to work on it. So IDP can do that. Or in QA or in the QA step or the research step in capture process, if you've got an assembly line for document capture, if there's an exception or a problematic case and you have to go to hit 6 information stores to determine if this is the right address, or did I get remarried, or did I have more children or whatever, a lot of the time is spent hitting multiple systems. You can use RPAs in conjunction with IDP to go out, grab stuff, understand it, so make it a text, extract the right information, and bring it back to you. And that's the fetch, collect. The next step, the more complicated, is understand. So it might be able to not just extract information, but make a suggestion as to what the answer should be. And this can be in those QA steps or questions or research, but also like in approval processes, whether it's an approval of a loan or a claim or whatever. And again, it's giving the human the suggestions, which then they can say yes, no, work on, and so on. This is all fairly straightforward, and you've got the human in the loop who's making the decisions. It's just if you've got a 2-hour approval process for a loan, the first hour is spent collecting information, the second hour is spent making decisions, eliminates that first hour. This kind of use case we're finding to be very interesting in early stages. But that collect, fetch, or collect, understand, and act type situations.